Okay, okay, okay. So am I audible? So our today's topic is basically BFS, Breadth First Search. Is BFS, Breadth First Search. So what it is basically? So let's suppose we have a graph. So what we have to do here is we have to write its BFS, where starting node is 6. Okay. So if our starting node is, let's begin from basic. So if our starting node is 1, so let us consider it as level 0. So we can go to 2 and 6, so it will be our level 1. And from 6 we can go to 7 and 9, it can be our level 2. From 2 we can go to 3 and 4, it can be our level 2. And from 9 we can't go anywhere, and from 7 we can go to 8, and from 4 we can go to 5. uh, we have to check the minimum level possible, so it's level 3. Okay, so this is our level order traversal. But if we our starting node is 6, what will be the case? So if our starting node will be 6, uh, the changes made will be reflected on its neighbor also. So here it is our starting node, so it will be 0th level, and from 6 we can go to 9 and 1, so it will be our level 1. And from 9 we can't go anywhere, it's also level 1. And from 1 we can go to 2, so it become our level 2. And from 7 we can go to 8, so it can also be our level 2. And from 2 we can go to 3 and 4, it can be our level 3. And from there we can go to 5. Okay, so this can be our level 4. So this is basically BFS. BFS is basically you are just flowing both side, flowing all side. So BFS is basically how wide you can go. Like next we will study DFS. DFS is only one side traversal, only go to depth. But in BFS you can see it is like a breadth. You are just uh, spreading. You are spreading in every direction you are connected to. So this is basically BFS. Okay, so let's do a quick question. First of all, let's copy this. Hope you understand this. I'm going to clean this. So we have to make a BFS. So basic approach of BFS is, first of all, make a queue. Let's make a queue, and we have to create a visited array. So I hope you know how to create a adjacency list. So let's suppose we have given an adjacency list, or we can create. Okay. So first of all, we have the nodes 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 0 has nothing, so empty. And neighbor of ones are 2 and 6, and neighbor of 2 are 3 and 4, and neighbor of 3 are only 2. The 1 also. For 1 it's 2 6, and for neighbor of 4 it is 2 and 5. These are basically connected nodes to a node. And 5, we have 5. 5 have 8 and 4, right? 8 and 4. And 6, 6 we have 179. Okay, and then 7 we have 6 and 8. And for 8 we have 5 and 7. And for 9 we have 6. Okay, so starting node is 1. We will create a visited array that will tell us if we reach to any node, and the child of that node is already visited, so we will not go forward with that child. Okay, so that's why we need a visited array. Let's create a visited array. So firstly we will push our starting node which is 1. We start with 1. Okay, and we create this 0 1 2 3 4 5 7 8 and 9. Okay, so 1, so we pushed 1. From 1, let's suppose all others are currently 0, only 1 is 1 now because it's visited marked. For now 1 is visited. So from 1 we can go to 2 and 6. So let's push 2 and 6, and 1 we visited, so pop it out. 2 is our front element now. So from 2 now, 2 and 6 are a part of our queue, like we can say they are visited. So 2 and 6 are also visited. From 2 we can go to 3 and 4. So let's mark 3 and 4 as visited. From 6 we can go to 1791. One is already visited, so we will skip it. So 7 and 9. Okay, uh, 7 and 9, let's mark them 7 and 9. And from now 3 we can go to 2, only 2. 2 is already done. Okay, from 4 we can go to 2 and 5. So let's push 5. 5 is okay, mark, let's mark. And from, we checked 4, right? From 7 we can go to 6 and 8. 6 is already present, let's add 8. 8, let's mark this chip. And from 9 we can go to 6, already done. From 5 we can go to 8 and 4, already done. And 8, from we can go to 5 and 7, which is already done. So this, what will we get our answer? 1 2 6 3 4 7 9, 3 4 7 9, 5 and 8. Okay, so let's code this. let's code this. So we have given an adjacency list like is seen in our example. We have to return a vector of BFS travel, whereas our starting node is 0. So we don't need to create a visited of size n plus 1. We will create a visited vector of, if you want bool, you can make bool, but I prefer 1 and 0. So visited of size, no size given of urgency, okay, n equal to urgency dot size. You can make it n. It's default 0. Its default values are zeros already. Okay, so we have to create a queue also. Queue into queue. So queue dot push 0. So while isn't queue dot empty, so your top element is, like, your current element is queue dot front, and we also have to make a vector which will store our answers. Vector in front, queue dot front, and you can equals answer dot push your current element. For auto, your adjacency of, for auto, your child of your adjacency list, the current node you are at, its child you will check. If already visited, dot mark instead of 0 equals to 1. If visited of child equal 1, we will skip. So what will we do? You can continue. Else what you can do? Firstly mark the child as visited. Then you dot push that child. Okay. Then you can return your answer. So what we did, we checked the current element, pop that element, okay, push that current element in your proto child of your current, okay, current. If visited, then continue. If not visited, make it 1. Okay, that's all. Answer dot push current. You have to push that. So we got. Let's submit. Okay, done. So in next lecture, we will learn about DFS, depth first search, which is basically also similar to BFS, but the little concept is different. So in our questions, we will use BFS and DFS, whichever you can want. So okay, subscribe and like. Thank you.